Okay, today we're going to look at patterns and equations. We're going to look at how you solve these tables that I know we've worked with a little bit all year long on our homework packets, and you've gradually, I think, figured out how these work. I want to show you a couple a little more complicated ones today, but show you how you can find an equation for a table, or also find a rule for a table. So when you're trying to find a rule for a table, what you're trying to do is find the relationship between each x and y group. And you're going to see as we work that what works for the first group may not work for the rest of the group. So this is really one of those try, check, and revise skills that are so important to have in math. So if we look right here, basically I can't tell anything from here because this is blank. I'm going to look at the ones that are filled in and see what I can figure out. And first I'm going to look at addition. How did I get from 3 to 8? Well, plus 5 would work. 3 plus 5 is 8. Let's look down here in this other one that's complete. Is 10 plus 5 15? And it is. So if you'll look at the table, we've taken the x value and we've added 5 to it to get the y value. So the equation for this table would be x plus 5 equals y. So let's go ahead and fill in the empty boxes. X is 0 plus 5 equals 5. Now here we're going to have to go backwards. Here we're going to say what plus 5 equals 12? Well, I know 7 plus 5 equals 12. So now I have a completed table just by looking at the relationship between the x and the y value. So let's work with a few and see how this goes. Let's find a rule for this table. Let's see if we can figure out what they've done here. From 0 to 3, it looks like maybe they've added 3. 0 plus 3 is 3. 1 plus 3 is 4. That one works too. 2 plus 3 is 5, and 3 plus 3 is 6. So I can safely say that the equation for this table is x, so this column here, all these numbers, plus 3 is going to give me the y column. 0 plus 3 is 3. 1 plus 3 is 4. 2 plus 3 is 5. 3 plus 3 is 6. So you're just substituting. You're plugging numbers in to either the x or the y value. Okay, this one gets a little bit more complicated. Again, let's skip this first one because it's blank. Let's go to here. Well, 1 plus 4 would be 5. So let's try this one. Is 2 plus 4 8? No. So that can't be the pattern in this table. If adding doesn't work, go to subtract, it's not subtracting because we know the numbers are getting bigger. So we know we're not subtracting. Let's try multiplying. Because if the number's getting bigger in the y column, you've either added or you've multiplied. So 1 times what equals 5? That would be 5. 2 times 5 is 10. That doesn't work either. So now we're going to have to get a little bit creative. Sometimes the x value may not only be what you do on that side of the equation, but you may have to multiply and then add. So let's try 2 plus 3. Let's do 2x plus 3. Well, let's start with 2x plus 4. Okay, so 2x would be 2 times 1, which is 2, plus 4 would be 6. That's not going to work. Let's try 2x plus 3. 2 times 1 is 2, plus 3 is 5. Okay, so 2x plus 3 works here. 2x plus 3 isn't going to work there. Wonder what this table is based on. 1 plus 4 is 5, but 2 plus 4 is not 8. 1 times 5 is 5, but 2 times 5 is not 8. Interesting. Well, we've tried 2x. Let's try 3x. What if we did 3x? So 3 times 1 would be 3. To get to 5, we would have to add 2 more. So let's try 3x plus 2. 3 times 1 is 3, plus 2 is 5. Works there. 3 times 2 is 6, plus 2 is 8. Hey, we may be on to something. That works there. Let's try it here. 3 times 3 is 9 plus 2 is 11. That works there. So now we've got to go work backwards. 3 times x, this would have to be 0. 3 times 0 is 0 plus 2 is 2. So this one was a little more tricky than the others. This is a definite try, check, and revise, especially when you get to where your x is not just a single value. It's a number times the x plus more. So this is really going to test your perseverance in math to see if you can stick with it until you can find the pattern. Okay, take a look at this. Which equation describes the pattern in the table below? So let's try each of these equations to see which one works. Now remember, if it works for the first one, that doesn't mean you're done. You need to make sure it works for all of them. So we have 6 plus x, which is 5. So 6 plus 5 equals y. 6 plus 5 does not equal 15. So we know, because it off the bat does not work for the first one, that it's not going to be our answer. Let's try B. 3x equals y. So 3 times 5 equals 15. Works there. 3x, 3 times 2 is 6 equals y. Yep, let's try this one. Let's try the next one. 3 times x, so 3 times 11 equals 33. That works. And let's try the same equation. 3 times 6 is 18, and that works. So we know this is our equation for this table. 3x equals y, or 3 times the value of x equals y. We can very quickly see that 3 plus x, so 3 plus 5 does not equal 15. And here, x plus 10, 5 plus 10 does equal 15, but if we go down to this one, x is 2, 2 plus 10 does not equal 6. So always make sure you try more than one equation and more than one x, y value before you choose your answer. Okay, look at this table. If we use the equation y equals x minus 3, or x minus 3 equals y, we need to fill in the table. So they've given us the equation here. So basically, what minus 3 equals 4? Well, 7 minus 3 equals 4. Here, x is 3, so 3 minus 3 equals 0. Here, the x is 10, so 10 minus 3 equals 7. And here, what minus 3 equals 6? And that would be 9. 9 minus 3 equals 6. Okay? Move on. Which equation describes the pattern in the table below? So here, again, we're just going to be substituting. 4 plus x equals y. 4 plus 2 does equal 6. 4 plus 5 equals 9. That works. 4 plus 7 equals 11. So this was easy because our very first choice was the correct answer. Now, this one's a little more of a challenge. Which equation could have been used to create the function table? And here are your choices. A, y equals x minus 4. So 8 equals 2 minus 4. That wouldn't work. 2 minus 4 would give you a negative number. So we know A is out. Let's try B. Y equals x plus 1. If x is 2, 2 plus 1 does not equal 8, it equals 3. So that one's out. Y equals x plus 6. So 8 equals 2 plus 6. Yeah, that one works. Y equals 5 plus 6. Nope, 5 plus 6 is 11. That doesn't work. So it's got to be this one. Let's make sure, though. Y equals 2x plus 4. So 2 times 2 is 4 plus 4 is 8. Works there. Y equals 2x. So 2 times 5 is 10 plus 4 is 14. Y equals 2 times 7 is 14 plus 4. That's 18. And y equals 2x, so 2 times 0 is 0, plus 4 equals 4. So our correct equation is y equals 2x plus 4. All right, here's what I'd like you to do tonight on your notes page. Part 1, Part 2, and Part 3. Part 1, you're coming up with an equation for this function table that works for every xy pair. Part 2, same thing, come up with an equation. Remember, equation has an equal sign, and it has to have an x and a y in it both. And then Part 3, explain to me how you did this. How do you find an equation for a table? Walk me through the steps to do that in your words. And remember, if you have trouble remembering how to figure this out, go back through the video and watch and listen again. And we will see you tomorrow in class.